Hey y'all, welcome back to my channel. Today is Math Monday, and today we're going to talk about all things irrational numbers. So we're going to look at integers and opposites and absolute value, comparing, ordering, and classifying them. Remember, in Math Monday, I do make a mistake for my students to identify for extra credit, and you can find these worksheets to follow along on my store for Teachers Pay Teachers. Let's get started. Let's now talk about rational numbers. Some key terms that you need to know when we're talking about rational numbers. The first one is whole numbers, and those are all of your counting numbers and zero. So that's all of the numbers that you're learning in kindergarten and first grade and second grade. So 0, 1, 2, 3, 4, 5, 6. Now integers, those are all whole numbers and their opposites. So we're now going on the opposite end of the number line where it starts with 0, -1, -2, -3. Then we also have rational numbers. And those are all numbers that can be expressed as a fraction in that form of A over B. Opposites. Opposites are the same distance from 0 on a number line. You can count how many places a number is from 0, go the opposite direction, the same number of places, and that will give you the opposite of the number. And a couple of tips when you're talking about opposites. The opposite of a positive number is always a negative number. And the opposite of a negative number is always a positive number. Let's look at some examples. We have what is the opposite of 6? So if I was on a number line with a 0 in the middle, and I counted up 1, 2, 3, 4, 5, 6, I would have to go the opposite direction since it took me 1, 2, 3, 4, 5, 6 places to get to 0. I have to go 6 places, so 1, 2, 3, 4, 5, 6 in the opposite direction. That would be -1, -2, -3, -4, -5, -6. The opposite of 6 is -6. What is the opposite of -3? On a number line. Now I'm starting on the negative side at -3. I go 1, 2, 3 places to 0. 1, 2, 3 places the opposite direction. The opposite of -3 is +3. Now we're going to look at finding the opposites of rational numbers. These are decimals, fractions, mixed numbers, whole numbers. Even with that negative sign, it is still a rational number. What is the opposite of -2 5/10? If I had a number line, we know that 2 5/10 would be between -2 and -3. So I go half a place, then 1 and 2, so 2.5 places to 0. So since my point is between -2 and -3, I know that it's going to have to be between +2 and +3. And just like our little tip, the opposite of a negative number is the same number, but positive. And what is the opposite of 12? Oh, that's supposed to say of. Sorry guys, typo. Of 12 3/4. Since it's a positive number, the opposite would be 12 3/4. Now this one's a fun one. What is the opposite of 0? If I'm on a number line and I'm looking at 0, I don't have to move any directions. I don't have to move any spaces. I stay right where I'm at. The opposite of 0 is 0. 0 is its own opposite. 0 is its own opposite. Our next example, what is the opposite of 4? So this is a fun one that always trips my students up. So if I'm at 0 and I'm at 4 and I have -4. So first we're going to look at what is the opposite. So I have to go to the opposite, and it says of the opposite. So since I have to find the opposite of the opposite, it goes back to that 4. So these two opposites kind of cancel each other out. The opposite of the opposite is +4. What is the opposite of -3 1/2? Same situation. The two opposites cancel each other out, which it makes you stay at that -3 1/2. Comparing. Y'all, autocorrect got me good on these slides. So that's supposed to say when comparing rational numbers, use inequality signs. I tell my students, when you see comparing, use those inequality signs. You can rewrite it in words, but showing that you know to compare numbers, you can use those inequality signs. That will impress your reader. Remember, this sign means less than, and this sign means greater than. Here are some tips. Positive numbers are always greater than negative numbers. Numbers to the left of the number line are always less than numbers to the right. Number lines will really help you when you are comparing rational numbers. Here is our example. Compare the following numbers. We have 20 and 14. If I roughly draft 20 and 14 on a number line, and I start at 0, I know if I'm counting 1, 2, 3, 4, 5, I get to 14, and then I will have 20. 6 more spaces would give me 20. Since that 14 is to the left of the number line, I know it's my least number. So I can say that 20 is greater than 14. If something costs $20, that price is greater than the $14. Now I have a -20 and a 14. That negative, think about it being -20 degrees. You know it's going to be colder than 14 degrees. And even on a number line, if I'm looking at 0, -20 will be on the left, 14 will be on the right. So -20 is less than 14. Now I have +20 and -14. So it switches. -14 will be on the left. +20 will be on the right. -14 is to the left, so that means that it will be less than 20. So my sign that I need to use is greater than. 20 is greater than -14. I have -20 and -14 if I'm looking at a number line. Both numbers are to the left of 0, so if I'm counting on a number line, -1, -2, -3, I'm going to get to -14 first. Then I'd go -15, -16, -17, -18, -19, -20. -20 is farther from 0. If I had a bank account and I had -$20, it would take me more money to get back to that 0 than it would for -14. I would rather owe $14 than owing $20. And just like those tips that we talked about, numbers that are farther to the left are your least numbers. I can say -20 is less than -14. Our next example, compare the following numbers. Now we're going to look at rational numbers. Those are decimals, our fractions, our mixed numbers. -3.5 and -3 1/10. If I'm looking at a number line, both of them will be to the left of 0. And they will be between -3 and -4. If I break this up into tenths, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I know -3 and 1/10, if I plotted it, would be here, and -3 and 5/10 would be here. That -3 and 5/10 is farther away from 0. It is more to the left on the number line, which means it is less than -3 and 1/10. Here we have a negative and a positive number. We really don't need to graph that because positive numbers are always greater than negative. -2 and 1/2 is less than 3 and 1/4. 0 and -5/10. If I'm on a number line and I'm looking at 0, here is where I can plot my first point. -5/10 is between 0 and -1. Since it is farther to the left on the number line, that means that 0 is greater than -5/10. My students love to say, oh, that's got a number. That means that it's greater than. No, 0 is always greater than any negative number. Now I have -2 and 3/4 and -3 and 1/2. Now without making a number line, let's think which one would be closer to 0. Whatever number is closer to 0 means that it is greater. I would say -2 without even looking at these fractions. -2 is closer to 0, which means -2 and 3/4 is greater than -3 and 1/2. Now let's look at ordering. Number lines are ordered least to greatest from left to right. Graph your numbers, and if it has least to greatest, if your question talks about being least to greatest, write your numbers as you see them on the number line left to right. If it has greatest to least, write your numbers as you see them right to left. This is huge, looking at those questions, looking to see, do they want least to greatest, do they want greatest to least, because that will determine how you list your numbers. Let's look at some examples. Order the following from least to greatest. If I'm on a number line, and I'm just roughly plotting these, I'm at 0. I know that -3 would be pretty close to 0. -12 would be farther to the left. 4 will be to the right of 0. And then we have 0, of course. Then we have -6. I know -6 will be between -3 and -12. And then I have +8, which I know that it is farther to the right of 4. I want these least to greatest, so I'm going to start all the way to the left with my numbers and start writing them. A tip that I tell my students is as you write the numbers, mark them out in your question. This tells you, have you used all of your numbers? Then I get to -6, and I get to -3. Oh, I forgot to mark my numbers out. 0. 0 is important to list. 4. And 8. Another tip I tell them is count how many numbers is in your question. 1, 2, 3, 4, 5, 6. and then count how many is in your answer. 1, 2, 3, 4, 5, 6. That helps you double check to make sure that you have all of your numbers listed. Let's talk about some key things here. Negative numbers are always least, and even though 12 is greater in the positive world, it is farther from 0. So it is my least number. Then I have my positive numbers as my greatest. And 0 is greater than any negative number. Next example. Order the following greatest to least. And we have some rational numbers here. So I'm on a number line. And I have 0, which is also my first number. I know that positive 5/10 will be pretty close to 0. And then my negative 5/10 will be to the left of 0. Then I have negative 5 and 25/100, which I know will be farther to the left of 0. 1 and 5/10 is to the right of 0 in the positive direction. And then I know that 4 and 5/10 will be farther to the right in the positive direction. This time I want greatest to least, so I'm going to start on the right, which the first number I get to is 4 and 5/10, 1 and 5/10, positive 5/10, 0. Forgot to put my negative sign on there. Negative 5/10. And I forgot to mark out my 0. And then I have negative 5 and 25/100. I'm going to show you another strategy that I also tell my students if they do not want to take the time to draw a number line. You can line all of your numbers up. When you do that, you need to line your decimals up. Zero doesn't have a decimal, but I can add a decimal 0 and it doesn't change the number. When I'm looking at these, I can look vertically. You can even draw your little line between your numbers. Always look left to right. We're actually wanting greatest to least, so we need to look at our positive numbers. Which one would be my greatest of my positive numbers? 0, 0, 1, or 4? I know that 4 would be. That's how we get our 4 and 5/10, and I always tell them mark out those numbers. Then of my positive numbers, I have 0, 0, and 1. So I know that 1 and 5/10 would be next. Mark it out. Then in my positive numbers, I still have 0 and 0. These are the same. That's when you'll come to this next column or your 10th place value. Which one is greater, 0 or 5? 5 is greater. I need to put that 5/10. I did add a decimal 0 here, but in your answer, you need to keep it in the original form. I look at my negative numbers. This is where it gets a little tricky. Which one is closer to 0? Which is 0. Negative 0 here, but it's negative 5/10. And then negative 5 and 25/100. Here are two methods, two strategies that you can use to order those numbers from greatest to least. Absolute value. The absolute value of a number is how many places a number is from 0. Absolute value can never be negative. Never, but if it has absolute value bars, which looks like this, when you see those bars, they're saying, hey, I want the absolute value of that number. How many places is that number from 0? Never put a negative on there unless there are certain circumstances, which you will see an example of that here in a little bit. Here are some examples. These are those absolute value bars. This is telling you, hey, you want the absolute value. If I look on a number line and I have positive 8, how many places would it take me to get back to 0, which would be 8? Same thing for negative 8 and 0. How many places would it take you to get to 0, which would be 8 places? Notice that these are different numbers, 8 and negative 8, but their absolute value is the same, which also tells you that 8 and negative 8 are opposites. Now, without using a number line, all you have to do, if it's negative, drop that negative sign, because negative 2 and 34/100 is just 2 and 34/100 places away from 0. Same thing if it was positive, you're just rewriting that number without a sign. The absolute value of 3 1/2 is 3 1/2. This is where there is a special circumstance. Notice that this negative is on the outside of the absolute value bars, which means you need to take the absolute value of 24 first, because you need to treat those almost like parentheses. In order of operations, parentheses always go first. So you need to treat those like parentheses and say, you need to do the absolute value of 24, which is 24, but then you have that negative sign on the outside. You want the opposite of the absolute value of 24. The absolute value of 24 is 24, and the opposite on the other side of the number line is negative 24. Let's look at this one. We want the opposite of the absolute value of negative 24. Treat these like parentheses. Negative 24, the absolute value is 24. We just drop that negative sign. Since it's on the outside, the opposite of 24 is negative 24. So when you have those negative signs outside of the absolute value bars, you drop it down. You're wanting the opposite of the absolute value. Classifying rational numbers. Numbers can be classified as whole numbers, integers, and rational numbers. Here are some examples. Just at like the beginning of this video, whole numbers, there's 0, 1, 2, 3, 4, 5, those numbers you've been using since kindergarten. Then you have integers. Now remember, integers are whole numbers and their opposites. So that's negative 3, positive 4, negative 24. Those are considered integers. Even 0 is considered an integer. Rational numbers. Rational numbers are whole numbers, integers, fractions, whole mixed numbers, decimals, all of those things. Anything that can be expressed as a fraction. When classifying, always list all that apply to a number. A little strategy that a teacher once showed me, and I love it, my students love it. Think about these as baskets. So we have whole number, we have integer, and we have rational numbers. If I picked a number like 5, and it was a ball, and these are baskets, I would put that 5 in the whole number basket. Well, since it's at the top of our list, that 5 can fall into the integers basket and the rational numbers basket. So that means that 5 is a whole number, integer, and rational number. Let's look at some examples. We want to classify the following numbers. Let's go ahead and draw those baskets again here, because it will be a great visual to use. Negative 27. It is a opposite of a whole number, negative 27, but it's not a whole number. Since it's a negative, I'm going to put it in that integer. So I can say it is an integer. Now notice these arrows go down. It's falling into those baskets. So balls, because of gravity, a little science in this Math Monday, it cannot go up. So it does drop down to rational numbers as well. So it is also a rational number. Now we have -5 1/4. -5 1/4, it's a mixed number. It's not a whole number, which means it can't be a whole number. A lot of people see that negative sign and say, oh, it's an integer. No, for it to be an integer, it has to be a whole number. It can't have that fraction on it. It can't be a mixed number. So it only falls in that rational basket. And since that rational basket doesn't go anywhere else, that -5 1/4 is just a rational number. 0. 0 is one of those fun ones. 0 is a whole number. But guess what? It also falls into that integer. And it also falls into rational numbers. And 28. 28 doesn't have a negative sign on it. It is a whole number. So it is a whole number and integer. That 4 1/4, it's a mixed number. It's not a whole number. It's not an integer. It's only rational. I hope you all learned something new, was able to review and gain a better understanding about rational numbers. If you like this video, give it a thumbs up and subscribe, and we will see you for Family Friday.